Hello everyone, and welcome back to another GIS lecture video. And in this GIS lecture video, what I want to talk about is attributes, attribute tables, and attribute queries. So if we remember back when we started talking about vector data, we said that there were three parts of vector data. Right, we said we spent a lot of time talking about the first part, which is the geometry, right, which was the location. We spent a lot of time talking about that. We talked briefly about this idea of the OID, FID, right? That's the unique identifier. Right, but we haven't spent too much time talking about the attributes. And what I want to do is I want to recap what attributes are and how they're structured as part of the vector data. So if we remember back to the idea of vector data, what we had is this idea that we can store information or attributes about a location in an attribute table. Right, and so the idea was that you would have, it looks kind of like an Excel spreadsheet, right? There would be rows and columns, right? And the idea was that the first row would be specific the attribute names. Right? But then each row after that right, would represent a feature. Right, so each row of the attribute table represents a specific location or a specific geometry, right? The first row is the attribute names. Each row after that represents a specific individual feature, right? And then we also know that, right, just like with an Excel spreadsheet, right, we can have multiple columns. The first column, right, is going to represent the OID. Right, so that first column is going to be the unique identifier. So for example, 1, 2, 3, etc. Right, after that though, right, any other additional columns that we have, right, these are all attributes. Okay, so let's go ahead and just quickly look at a sort of real world example of what this looks like. All right, so this is a snippet of an attribute table of cities. Right, and so what we know is that, right, this is our OID. Right, and we know that each one of these rows, right, represents a single city. Right, each row is a feature. In this case, a feature is a city. Right, and we know that each column, right, represents an attribute. Right, and so just as a quick refresher, right, the attribute names, right, we have name, st, stfips, placefips, capital, pop class, and pop 2010, right? And so if this was an actual data set we were actually going to use for a real application, right, it would be our job to understand what each of these means. Right. In the real world, you should understand what each attribute means. Right? If you have a value, you should be able to interpret that value in the context of what the attribute means. Right? In this case, right, pop 2010, that's pretty simply the population of the city. Right? In 2010. So if we were going to use that variable later, we would be confident that we know what it means. So the first step of any analysis ever is to crack open the attribute table, figure out what attributes you need, and then figure out what they are doing and what they mean so that when you use them, you're confident that you understand what's going on. Okay? So just to recap what we've talked about, right? An attribute table consists of a row of object IDs, right? A row of object IDs so that we know, right, the unique identifier. This object ID connects back to the geometry so that when we do queries on these, which we'll talk about in a minute, we can also grab the geometry as well. Each row represents a specific feature. So in this case, each row represents a city specifically. Each column represents an attribute, so a piece of information that we have about a location. The first row of the table here always represents the names of the attributes. And you should always know what attributes you're using. You should always know what they mean. So hopefully that makes sense. So let's talk about something useful that we might want to do once we understand the attribute table and what we're looking at. Well, I think the most important thing that we can do with attributes are what are called attribute queries. Right? Attribute queries. And basically, the goal of an attribute query is to go through an attribute table and pull out certain features based on their attributes. Right, again, we're trying to select certain features based on their attributes. And you can kind of imagine intuitively why this would be useful. Right, if, for example, we had a point data set of crimes and you were interested in gun crimes specifically, well, it would be useful to be able to open up that data set and say, hey, give me, or select, I should say, select all of the crimes where a gun was involved. And you would have an attribute that would allow you to make that distinction, right? And so when it comes to doing attribute queries, there's going to be three things that we have to have. The first thing we have to have is a variable name, right? So this is going to control what variable we're looking at. Right, then we need to have some sort of a comparison. Right, and this is going to be a mathematical comparison to be executed. right? And then the last piece is going to be a value, right? And this value is going to be the value against which that variable is compared. Right? And so basically what we're going to do is we're going to pick and generate these three pieces, a variable, a comparison, and a value to generate an expression. What's going to happen is we're going to take that expression that we make and we're going to look at each feature in the data set, run that expression through. If the comparison is true, right? So if whatever the variable is, when you do the comparison to the value is true, we keep it, right? That's how we select things. If it's not true, we reject it. So it's not selected. And I know this might not make sense right away, but we're going to look at a bunch of examples, so hopefully this will start to become more clear. But at the end of the day, every attribute query that we write is going to have a variable name telling us what variable to look at, a mathematical comparison saying how are we comparing it, and then a value against which we're going to actually compare the variable. Okay. So variable name is going to come from the data set. The value we're going to pick ourselves because that's the thing that we're going to control for. And then we have this comparison. And I want to take just a minute and I want to talk about the types of comparisons that we can have. Right? So if you're used to sort of logical operators, this is going to look very similar. Right? So in terms of comparisons, what we can have is we can have things like equal to, right, which we express as an equals. Right? So is the variable equal to some value? Right? For example, if we were to think about the states, right, is the state's name equal to Alabama? That would find you all of the cities where the state name is Alabama. Right? We can have less than, right? We can have greater than, right? So if we think about that table with the cities, right, we could say, is the population less than 1 million? Right? That would grab all of the cities whose population 2010 is less than 1 million. Same thing with greater than. Right? We can have less than equal to. Right? That's typically something like that. We can have greater than equal to. Right, I want to take a second here because these two you typically won't see less than equal to, greater than equal to. Typically when we talk about this in common English, less than or equal to is typically referred to as at most. Right, greater than or equal to is typically called at least. Right, if we have at least 15 people, that's greater than or equal to 15. Right, if we have at most 50 people, that would be less than or equal to 50. Right. So whenever you hear at most, it's less than or equal to. Whenever you hear at least, that's greater than or equal to. And then finally, we can have, right, not equal. Right. So that's going to have, right, equal to, not equal is an equal sign with a cross through it. This is basically going to go through and say, hey, wherever the variable is not equal to the value, give me that. Right? So just to kind of recap what these look like, right? Less than or equal to, greater than or equal to, is equal to, is not equal to, greater than, less than. And again, I just want to point out because it's very important, right? Less than or equal to is often called at most. Greater than or equal to is often called at least. Okay, so let's go ahead and walk through some examples of constructing basic queries. So let's imagine that we have census tract data, and we have the attribute population 2020, which would contain the population of that census tract in 2020. And we're tasked with finding all the census tracts with a population of at least 100 people. So just to recap, right, the structure of every attribute that we're going to write starts with var name, right, the variable name that we want to compare for the data set, some sort of comparison that we've talked about, and then some value to make the comparison against, right? So these are the three pieces that we're going to have for every single query that we ever write. So let's go ahead and look at our example here and figure out which pieces go where. So the first thing we need to do is find the variable name. Right, in this case, right, we want to find all the census tracts with a population of at least 1,000, and we know that the attribute in the data set is pop 2020. So this pop 2020, right, this is going to be our var name. So we're going to have pop 2020, pop 2020, right? The next piece is the comparison, right? What type of mathematical operation are we going to be making to compare the value to the variable name? Well, we know down here, right, just as a shorthand to keep track of stuff, these are the basic options that we have. So let's go ahead and see what we're trying to do, right? We're trying to find all the census tracts with a population of at least 1,000 people, right? This at least right here, right? This is going to be an indication of the type of comparison that we want to make, right? At least. So we know what comparison we're making, but how do we express that in our sort of query up here? Well, remember when we said at least is typically whenever you see at least, that's going to be greater than or equal to, right? So our mathematical comparison here is going to be greater than or equal to. And then finally, right, we have to grab the value. What is the value that we're going to make this comparison of pop 2020 against? Well, our value, right, we're going to try to find the population of at least 1,000 people. Right, this 1,000 here, right, this is going to be our value. Right, so if we were to write that out sort of not in pieces like that, right, our finalized query is going to be pop 2020 greater than or equal to 1,000. Right. Okay, so let's go ahead and look at another example. Right, so we have counties in this case with the attribute ST, which stands for the state name the county belongs to. And we want to find all counties that are part of Florida. So let's break that down again, right? What is our variable name that we're interested in? Well, the only attribute that we have in this case, right, is ST. So we would do ST, right? We want to find all the counties that are part of Florida. So what we're looking for is we're looking for where the state name is equal to, right? Because that's, right, sort of inferred from are a part of. We're inferring that we want the state name to equal. What do we want it to equal? We want it to equal, right, Florida. Right? So again, breaking all those parts down, we have ST equals Florida. Right, this would go through the data set and it would pull out all of the counties whose state name is Florida. Let's look at one more example of a basic query. So this should actually be example 3. Right? You have a county's data set with the attribute ST. We've already looked at this. This is the exact same data set. But instead of finding the counties that are part of Florida, we want to find the counties that are not part of Michigan. So the first part is the same, right? We have ST coming from here, right? This is the variable name that we're interested in. We have our value. It's going to be Michigan, right? But we want to get all of the states that are not part. So we're going to say, hey, for each county, is your name not Michigan, right? And the sort of comparison operator that we have for not is this equal sign with a slash through it, right? This is going to say, if your state name is not equal to Michigan, select you. Otherwise, if your state name is Michigan, we can get rid of you, right? So to write that out, right, ST not equal to Michigan. Okay. So that is how we set up basic queries. So let's go ahead and take a second and go through some review questions. So at this point, what I'm going to do is I'm going to present you with a question, pause the video, try and work through it on your own, and then we'll come back and we'll go through it together. So let's look at the first question. You were given a point data set of recently inspected fire hydrants. The fire marshal needs to know how many of the hydrants have a sustained pressure of less than 15 psi so that they can be examined, repaired, and replaced. So the idea here is that we want to write a query that is going to return the hydrants that have less than 15 psi using the attribute suspress. So go ahead, pause the video, try to write a query that will answer this, and then we'll come back together and work through the answer. Okay, so let's go ahead and work through the answer together. Well, we know that we need to start off with our variable name, and we were given that the variable name is suspress. So we know that we're going to have suspress. Right, for the comparison, right, we know that we need to have a pressure of less than. So this is going to be the less than operator. And because it is not at most, we know that we're not going to have the equals part. We are strictly using, right, we're strictly using less than. Strictly using less than here. Less than 15 psi, right, that's this piece right here. 15 psi. So suspress less than 15. Hopefully you got that one right. Let's go ahead and look at another review question. So the NIH just published a county-level data set of COVID-19 hospitalization rates. Your GIS class is trying to investigate the relationship between high hospitalization rates and comorbidities. The first step is to isolate counties with high hospitalization rates of at least 25%. Write a query to accomplish this. The attribute for hospitalization rates is hosprate. So go ahead, pause the video, try and write up this query, and then we'll go through it together. Okay, hopefully you were able to figure it out, but let's go through it together. So again, we always start with identifying the variable of interest here. In this case, right, again, we're sort of given it as hosprate. So we're going to have hosprate. Right, our comparison, we have the at least here. And again, whenever you see at least, that is an indication that you have a greater than or equal to. Right, because again, whenever we use English, whenever we talk about greater than or equal to, we usually use the term at least. So this is greater than or equal to, and then our value is going to be, right, this 25%. Right, so hosprate greater than or equal to 25. Let's do one last review question. So that's how we handle basic queries. Let's look at making this a little bit more advanced by doing something called compound queries. Right. So with the basic queries, what we were doing is we were writing up a comparison of one variable to one value. With compound queries, what we can do is we can start to connect multiple queries together. Right. So we can start to compare multiple variables, or maybe the same variable to multiple values. Right. So the idea is that we can start to piece together more complicated selection criteria. Right. So for example, maybe we were interested in thinking about the cities again, right? Maybe we want to get the cities that are part of Florida, but also have a population of greater than 1 million, right? We can put those two things together in a compound query. So the way that compound queries work is you always have at least two queries, right? So we'll say this with query 1, query 2, query 3. So in this case, right, we have 3 queries, but you always have to have a minimum of 2 for a compound query. And then in between each query, we have a connector. Actually, let's make that a different color. Right, in between each query, you have a connector. Right, that connects the queries together. Now there are multiple connectors, but we're only going to focus on 2 because they are far and above. Well, actually, we'll focus on 3 because they are far and above the most commonly used, and the first 2 are almost exclusively. So the 3 connectors we have are, and they're English words, right? We have and, we have or, and we have not. Right? So the word and means that you have to meet all of the criteria. Oops. Connected with and. I'm going to move these over a little bit, give us a little bit of room here. Right? Or must meet any criteria connected with or. And then not isn't really used that often, but basically you must not meet this requirement. We're actually going to largely ignore not because it's not very usually used. Generally, what would happen with not is you would just use you would structure the query differently. So we're going to focus mostly on and or. And the way that I like to think of this, because sometimes it can get a little bit confusing when you're trying to differentiate between the two, I like to think of it like you're at a restaurant ordering food. Right, and so the feature would be whatever dish the waiter brings out to you. The queries would be how you structure your order, right? And so, for example, dealing with the and, where you must meet all the criteria that are connected with and. So this would be, for example, if you ordered a hot hamburger at the restaurant and you told the waiter that I want a hamburger with ketchup and mustard, right? That would mean that the hamburger has to have ketchup on it and it also has to have mustard on it. If it doesn't have both, you won't eat it, right? So and means that it has to meet all of the criteria. So again, think about the hamburger, right? It has to have the ketchup and it has to have the mustard for you to be able to eat it, right? For the or, right, it just has to meet any one of the criteria, right? So for example, if you're ordering food in this case, right, you're looking at the menu and you don't really know exactly what you want. So you're like, I'll have a hot dog or a hamburger, right? Or maybe I'll have a Coke or a Pepsi. And then whichever one the waiter brings out, you'll be fine with, as long as it's a Coke or a Pepsi, right? So that's how or works, right? As long as it meets one of them, you keep it. So I know this can be a little bit confusing. So let's go ahead and go through several examples of this idea of compound queries. So let's imagine that we have census tract data with a population in 2020 and the number of occupancies or households that are renting. And the idea is that we want to find all of the census tracts that have a population of at least 1,000 and over 50% rental housing. Right. And so if we think about this compared to what we've done in the past, right, we're going to build our first query here of pop 2020. Right. At least means we want to use a greater than or equal to 1,000. Right. We've done this exact query before. We have another query, right? Great, over 50% rental housing. So that's going to be OCC rent, right, greater than 50. So I've built two separate queries here, one based on the 2020 population to cover this first piece, and then one based on the occurrence of rental based on this second piece. Now the idea here is that it needs to meet both of these requirements to be selected, right? Because we want to have, it has to have at least 1,000 people and have over 50% housing. Now the nice thing is whenever you see and in sentences like this, typically speaking, that translates to an and in the query, right? We need to have it have this and have that. Okay, so in this case, in order for it to be selected, it has to meet both, right? Just make this abundantly clear, right? Because of the and, right, it must meet both requirements. So let's look at another example. Right, in this case, right, we have some roadways and we're trying to figure out whether or not they need to be maintained or paved. And so the idea is we have two different conditions. We have the surf type, so that's what type of surface the road has. And then we have the condition, which is the quality of the road itself. And the idea is that we want to find roads that need to have paving or repaving in the next 5 years. So one situation where that could occur would be if the condition is poor, meaning the road is not maintained. Another would be if the type of road is dirt, because we would want to convert that to paving. So we want to find all of the roads that meet those two conditions. So in this case, right, again, we're going to break this up into two separate queries, right? The condition is poor. This condition is poor, right? This is one condition. So we can write a query for that, right? Condition equals poor, right? That's a single query based on this piece here, right? We have another query that we can write, surface type of dirt, right? Surf type equals dirt. Oop, let's not capitalize all that. That's unnecessary, right? And again, all I've done is I've taken the two different criteria, right? Surface type of dirt and condition of poor, and I've turned those into individual queries. Now, in this case, right, we can grab them in either way, right? If it's a poor condition road, we want it. If it's a dirt road, we want it. So it only has to satisfy one of these conditions for us to want to return it. So in that case, right, if it can meet either or both or any, right, we're going to use or here. Right, again, just to be clear, right, because of this or, right, can meet right, the feature can meet either condition. Right. So let's go through some review questions. So the first question is going to be, we're dealing with the Housing and Urban Development Agency, so HUD, and basically we're trying to figure out which areas we're going to prioritize funding to. So the idea is that we're looking for those census tracts that have both a high cost of housing and a low minimum wage or median wage. And we're given the two variables that we want, med HP for the housing price and med wage for the wage. So go ahead and read through the question and try to answer it on your own. Okay, let's go ahead and work through the problem together. So just like before, we're going to break this down into its different queries. So the first query that we want to do is we want to find the median house price of at least $40,000. Right, this is the first. Right, this is the first kind of query that we have here. And turning that into a query, we have median house price, which is med HP, of at least, and we know whenever we see at least, that means greater than or equal to 40,000 or 400,000, right? We also have this second piece here of median wage of at most 30,000. And we know that the attribute here is med wage. So we know that we can make a second query of med wage. And when we see at most, we know that that is a less than or equal to 30,000, right? And because we have this and here, we know that we need to satisfy both of these criteria. So we would use the connector and. So we need to find the census tracts that have a median housing price of 400,000, greater than or equal to 400,000, and a median wage of less than 30. So this would be the compound query here. All right, let's go through another review question. So this time we're working for the Coast Guard, and we want to analyze data related to shark attacks. In this case, we want beaches that have greater than 300 visitors on days in either June or July with at least 15 shark observations. The attributes for daily visitors is day viz, the attribute for sharks is shark count, and the attribute for month is month. And I'm going to warn you, there's actually going to be 4 queries built into this. So go ahead, give it a shot, and then we'll come back together to try to figure out the answer. Okay, so let's go ahead and work through our answer here. So like I said before, there's actually 4 queries in here. We need to look at 300 visitors relative to Davis. Actually, let's color code that. right? We know we need to do a 300 visitors tied to Davis. We know we need to do a 15 shark observations relative to shark count. But then we also need to do two comparisons, right, of June to month, but also July to month, right? And this one here is a little bit tricky because we can only test, right, if we remember back to our queries, right, each query only has one value. So June to month and July to month are going to be two separate queries. So let's go ahead and write that down. Well, the first thing that we want to do, right, is we want to get whether or not the month is in June or July. So that's going to be month, right, is equal to June, and month is equal to July, right? And because it can be either June or July, right, we connect these with an or. Right, we know that we want to have greater than 300 visitors, so that's going to be 300. Backwards. That's going to be Davis, right, is greater than 300. And then we also know that we want to have at least 15 shark observations relative to shark count. Whenever we see at least, we know that that means greater than or equal to 15. Now, we know that what we're looking for are days that meet the month criteria and have this many visitors and have this many sharks, right? Because it has to meet either May or June, but then it has to have 300 visitors and sharks. So it's either one of these, but then all of those. This one was a little bit more complicated. Hopefully you got it right. Hopefully the explanation makes sense. So let's go ahead and talk about the last piece here, which is going to be executing queries. Because I think executing queries is actually going to be the part where everything sort of comes together and we're able to sort of really understand what's happening, why the queries are structured the way they are, and it actually helps us understand queries better. So just to sort of reiterate the idea here, that what happens under the hood is we take that query that we made and we run each feature through the query, right? So, right, for each feature in a data set, right? And again, keep in mind when we say feature, we mean row of attribute table. Right, so for each feature in the data set, right, we run the query. Right, if true, feature is selected. Right, if false, feature is not selected. Okay. So basically, again, right, what we're going to be doing is we've built our query. We're going to look at each feature or each row. If we run that through and it comes back true, meaning that the comparison is correct, then we select it. That's a feature that we want to consider. If it is false, then we don't, then it's not selected. So this is sort of the fundamental under the hood of how the selection or attribute queries work. So let's go ahead and look at a couple of examples here. So we have our attribute table from earlier on, and we're going to look at the example. We're going to execute the query of st equals al. And what I'm going to do here is if it passes, I'm going to put a green mark. If it fails, I'm going to put a red mark. So ST equals AL. So what we're going to do is we're going to look at the state variable. So that's going to be this column here, right? So we're looking at this column here. And then we're going to look for whether or not each row has an ST value of AL. So in this case, right, this one's good, this one's good, this one's good, right? Nope, no, 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 no. Right, and you can see that all I'm doing is I'm looking and I'm saying, does this value match AL? Right. So at the end of the day, what we get back is we return 3 features. Right. OID 6, 22, and 40. Right. OID 6, OID 22, and OID 40. So that's a pretty straightforward one. Let's go ahead and look at another example. Population 2010 greater than or equal to 1 million. Right, so now in this case, right, we're going to be looking at the pop 2010. Right, we're looking at this variable, and we're going to be saying, is this value greater than or equal to 1 million? And again, I'm just going to run through. If it's not, I'll put a red mark. If it is, I'll put a green. Right, and again, I'm just comparing this value to 1 million. Right, and so in this case, we would get 1, 2, 3, 4 features returned. Right, we would return OID 110, OID 1263, (2573) and 3090. All right, let's go ahead and look at another example here. This is a compound query. And this is actually a bit tricky, so I'm actually going to let you try to think through this really quickly. I know it's not technically a review question, but think through it really quickly before I go through it. Okay, so what I'm going to do is I'm going to actually do both of them. So I'm going to do the pop class equals 5 in green, and I'm going to do the pop class equals 9 in blue. So anything that equals 5, I'm going to mark it green. Okay. Anything that equals 9, I'm going to mark in blue. Right. So this is the part where the trick comes in. Because we have this and here, right? Because we have this and here, right? This means that a feature must meet all queries, right? So what that means realistically is that we're looking for a feature that has both a green mark and a blue mark, right? The problem is in this case, right, none of them have a green mark or a blue mark. So in this case, we would actually return no features, right? Because none of them meet both the criteria. So I would go out on a limb and say that maybe this was a typo and what we actually meant to do was an or here. So let's go ahead and do the exact same thing again with this slight difference of having the connector be an or rather than an and. So we're going to do the same thing. We're going to select, just to keep the colors the same, we're going to select 9 in blue and 5 in green. Right. So now in this case, right, because we have an or here, because the connector in this case is an or, what happens is it only has to meet 1. To be selected. Right. So basically, if it has a green check mark or a blue check mark, we can call it selected. So in this case, we have 1, 2, 3, 4, 5, 6. So we return 6 features. Right. I'm not gonna bother grabbing the object IDs here. But the idea is that by switching from and to or, we now get features, whereas the previous one, we didn't get any. Let's look at one more example. Pop class equals 10 and capital equals state. So in this case, we're actually looking at 2 different variables, and we're making comparisons against 2 different values. So let's go ahead and just like before, I'll mark the pop class in green, and I will mark the capital in blue. So pop class, we're looking at the pop class variable, and we're saying, is the pop class equal to 10? So pop class is equal to 10 here, 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 and here. Right, so if I'm going too fast, pause the video, go back and rewatch, make sure you understand how I'm doing that. Right, the idea is that we're comparing pop class to 10. If it's true, if it equals 10, we mark it. If not, we don't. Right. So then the second query here is capital equals state. So in this case, right, we're looking at the capital variable, and we're saying, is it state? Right. And so again, right, we have this and connector, which means that you have to meet both. Right, which means that in order for us to select it, it has to have both a green and a blue. And the only place that meets both green and blue is this one here, right? Because this has blue but not green, right? This has green but not blue. The only place that has green and blue is this one right here, which is Phoenix. Right, so this returns 1 feature. It's the OID of Phoenix, which is 110. Right. So hopefully that made sense. Let's go ahead and quickly do a couple of review questions. So for these review questions, we're going to be using a slightly different attribute table than the one we just did. We're actually using this attribute table over here. So in this case, we're talking about a data set of invasive of species. Some of them are invasive, some of them aren't, and we have 2 different measures: the height of the individual tree and the width of the trunk at breast height. So the questions are going to basically be how many features result from a query. So in this case, right, how many features or how many individuals would be returned from the query invasives equals no. So go ahead, pause the video, work through the answer, and then we'll come back through and discuss. Okay, so the idea here is invasive equals no. We're looking at this variable here, the invasive variable, and we're basically saying, does this variable equal no? And we know that it does here through here, right? All of these are invasive equals no. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is going to return 13 features. Right. So hopefully that made sense. This was just a basic query. Let's go ahead and try something a little more complicated. Let's try this one. So in this case, how many features would be returned given this query? So go ahead, pause the video, give it a shot, and then we'll come back and return. Okay, so this one has the operator not equal. Right, and with not equal, basically we're returning everything where the location is not locust. So basically everything that's not locust. So this, everything that is not locust. Right. So I'm going to cheat a little bit and use the IDs as the count. So this is going to return 26. All right. Let's do one more. It's going to be slightly more complicated. Let's do this one right here. So we have this is the query, and let's go ahead and see what comes when we do that. Okay, so for this one, we have three separate queries. We have this query here. We have this query here. And then we have this query here. So I'm going to just quickly go through and check each one based on the color. So species equals tree of heaven. That's going to mark this one, this one, this one, this one, this one. Right? Or species equals locus. Right? And because these are connected with or, we would return all of these. So as of right now, we have 16 features. But we can't stop here because we have this other query here, this diameter at breast height, or DBH, greater than or equal to 10. So that's going to grab this one, this one, this one, right? And so what happens is, because this is an and, it means it has to meet these two, one of these two, and this one. So basically it has to either be red and yellow or blue and yellow to be returned. Right? And so if we count up the ones that are like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we had 16 that met the species requirements, but only 11. Let me just recount that to make sure. Yep. We only had 11 features returned. So hopefully that made sense, this idea that we have this part up here being an or, and this part down here being an and, the way that we would proceed with that. So hopefully this all made sense, and as always, if you have any questions, please reach out. Thank you.